Next, I'm thrilled to introduce a speaker who is one of the youngest and most high-profile founders working in AI today. He taught himself to code at a young age, and after high school, went straight to Silicon Valley to work as a software engineer. After a few years, he enrolled at MIT to study machine learning, but dropped out after just a year to found his own company. His startup, Scale AI, which he founded in 2016, is a data platform that produces labeled datasets for other companies to use to train their own AIs. Scale's clients include OpenAI, General Motors, and Toyota. And in December, Scale announced they'd closed a Series D fundraising round, valuing the company at more than $3.5 billion. He's here to tell us why he thinks, as he said, data is the new code. And I'm really looking forward to hearing what he has to say. With that, I'd like to welcome Alexander Wang to EmTech Digital. He'll give a short presentation, and then we'll have some time for questions after his talk. Alexander, thank you for joining us.
Thank you so much, Amy. I'm really excited to be here. I'm excited to talk through data is the new code. Wonderful. So yeah, I think the title really said it all, but it's a concept that we're really excited about at Scale. You know, we really think we're at this tipping point in the deployment of AI through many industries, where businesses in every industry need to be thinking about their AI strategy today or be left behind. And at the core and at the foundation of these data strategies is data. You know, we believe that AI will be as transformative as the internet in the fullness of time, and having the right data strategy in place will have implication for businesses for decades to come, just like how having the right code and technology strategy was important for the past few decades. So the pain or the real problem that we're noticing in the actual deployment and proliferation of machine learning and AI is that AI development follows a fundamentally different paradigm from traditional software development. So if you kind of think about traditional software development, you go through this cycle of or an organization would go through this cycle of writing code, deploying it, evaluating it, and writing more code. And writing code is sort of this critical component in that cycle because of it results in the system getting better. And so the sort of like core improvement loop for traditional software development is you write code, you deploy, you evaluate, you write more code. Well, the same thing is true in AI development. In any sort of development cycle, you need some core improvement cycle. How do you make things better? How do you make the system better? And the real thing is that, you know, per the title, data is the new code. Data is actually what allows these systems and these algorithms to improve over time versus code. And so the virtuous improvement cycle for AI development, and this is true across many of the organizations that do heavy-duty AI development, is this data-centric development cycle. It's about labeling data, training an algorithm, evaluating that algorithm, and then finding more data to label it. So data is this huge bottleneck to creating meaningful AI algorithms, as well as maintaining and improving existing algorithms. And the issue is that it requires a lot of time and resources to go through this process of labeling data. Just like how in traditional software development, writing code is like this incredibly time and resource intensive process. And so the other key takeaway is that AI development is not this one and done process. Oftentimes, I think we think of AI development, or we think of building these products as this sort of, you do it once and then you sort of you move on and you have an AI system. It actually requires this constant cycle of maintenance and updating, just like how a lot of traditional software systems require in the form of code updates. And so that's why it's very important that the data is sort of viewed as the foundation of an AI lifecycle. You know, I think one of the sort of intuitive ways to put this is that bad data in results in bad AI out. And I think a bunch of speakers have talked about this, but the challenge is that, you know, a lot of these AI algorithms are truly just reflections of the data that they're trained on. And so, you know, just like how children learn from their parents, or children learn bad habits from their parents, you know, these algorithms are going to learn bad habits from the data in which they're trained on. And what's more, you know, developing AI on top of, you know, quote unquote bad data means not only will it not live up to the potential, will it not be like this incredible AI that solves all the problems that we need, it actually frankly can be dangerous. It can lead to safety risks, For example, for a self-driving car company, training algorithms on bad data could result in more accidents or a failure to identify obstacles or pedestrians. It results in bias. There's been a lot of cases, recently, for the past while, of cases where algorithms have significant amounts of bias, which results in real harms for the real world. And then, it results in inaccurate results and recommendations, which ultimately hamstring the efficacy of these systems. And so data ends up being this really important thing. And I think one thing for most organizations is that investing in data often feels somewhat like a leap of faith. And this is because you don't know how valuable large and super high quality data sets are for your algorithms unless you've actually seen it in action. And because AI and machine learning is a relatively new field, there's actually not very many organizations that have seen the sort of nirvana state, or the sort of like the wonderful future where there's lots and lots of incredible data, and that data powers incredible algorithms. And so it can feel like a leap of faith to invest very significantly into your data today in building out a solid data strategy and have data sets that are large and high quality and well labeled. But that's actually really requisite for high performing AI. And in some sense, one of the key bottlenecks that's holding back a lot of organizations today is this inability to sort of make that leap of faith. And so what's kind of the right way to solve this problem? I think one thing that a lot of folks talk about is that annotation or labeled data and supervised learning, like was said previously, it isn't scalable. And one of the reasons for that is historically this is done in a very manual process. And I think it requires this question of like, how do we innovate on that manual process? And so Scale System, what we've built is a system that combines machine learning and human insight to be able to ultimately result in a much more efficient process for producing data, and hopefully a process that will scale that scales the efficiency exponentially as the data requirements of these algorithms continue to grow exponentially. And so machine learning is capable of processing high volumes of data with reasonable accuracy, but again, it's not going to be quite as accurate as you need for your algorithms. And so there's this requisite layer of human review, which allows for high judgment work to be completed by skilled experts to maintain utmost quality on these systems. And then over time, you're able to automate, or at scale, we're able to automate more and more of the human work, or the work that would be done by humans, by enabling the machine learning to get smarter. And then that allows the expert labels to focus more on the long tail and focus more on the edge cases, which the algorithms aren't performing well at already. And so it's this combination of sort of, annotation as an active learning process is maybe one way to look at it. And machine learning also enables this continuous improvement of the data by being able to quickly identify which data is most important for the algorithms, and then be able to make sure that you're always spending effort on the core improvement cycle of the algorithm. And so we think that this paradigm, whether it's Scale System or other systems, is actually really critical for the sort of the mass expansion of AI, because the needs of data are going to grow pretty exponentially over the following years. And it's very important that businesses are able to scale their AI programs as the amount of data requisite actually scales exponentially. Oops. Okay, there we go. And so with the right data strategy, we've seen businesses across every industry see the real world impacts of AI. And so I think one of the things that, like, one of the common criticisms of AI for a very long time was that it really was only in the hands of very few companies in the past, sort of the tech giants of before. And I think right now we're seeing this process by which many more organizations are actually able to utilize AI technology and be successful. And a huge part of that is having the right AI data strategy. And so, for example, Toyota Research Institute, Toyota is building the next generation of autonomous vehicles, and creating massive amounts of training data without sacrificing on quality, if anything, improving quality, was necessary to fuel their mission. One of the things that they've actually announced is that Toyota's self-driving vehicles are going to be powering the Tokyo Olympics later this year. The athletes at the Tokyo Olympics are going to be traveling through these self-driving vehicles. And so this required huge amounts of data, requires incredibly safe systems. And by leveraging machine learning for majority of the annotation and then humans to verify the safety and quality, scale, we were able to partner with Toyota to build this data foundation, which allowed them to significantly increase the amount of data flowing through the system and ultimately build safer systems. States title, States title is revolutioning real estate, and they knew that AI was going to be critical to bringing an old industry like home buying into the 21st century. But one of their bottlenecks in the past was that they'd been trying to tackle the data problem in a very manual, unscalable way. And actually, the key problem was that the quality of the data was nowhere close to be able to actually automate these processes for their customers and revolutionizing the real estate business. And so what we're able to do with States title is, again, through leveraging a combination of humans and machines, improve the accuracy of these systems to actually enable them, improve the accuracy of the data, which improved the accuracy of the systems, which therefore enabled, States title to actually fully automate processes that were used in the real estate process. And that's a big change. And then lastly, Honey, which is a subsidiary of PayPal, which is an online shopping platform trusted by millions of members who count on Honey for shopping offers and deal discovery. For merchants, Honey is also a way for them to help attract new customers and drive incremental sales. We're able to power a huge amount of seamless integration of efficiently validating and categorizing millions of products to ultimately enable a better AI experience for their customers. And so, in the future, we believe that AI can be expanded even further beyond a lot of these use cases to fields including the medical field, such as skin type medical imaging or pathology medical imaging. And we think that this sort of data strategy approach is sort of the key unlock, which will allow many industries to be able to adopt AI in a big way. And I think that, there we go.
Thank you so much for taking us through that, Alexander. Really interesting stuff. And just like last time, I'm going to start by asking a few of my own questions and then get to as many from our audience as I can. So clearly, you really believe in the power of labeling data, on your company's website. And I think you said it today. You even go so far as to say that labeled data is even more powerful than algorithms. Obviously, you just heard what Hamid said, that moving away from labeling data and toward unsupervised learning is really the future of practical AI, and that relying on labeled data sets is too restrictive. So I have to ask, what's your response to that?
Yeah, I think that it's a really interesting question. One thing that we do believe really strongly at scale is that the way in which humans will provide input to these machine learning systems is going to evolve over time. And so maybe the exact paradigm of how data is labeled today is not the right paradigm going into the future, right? Like it might not be the case that to train an algorithm that can detect dogs and images, that you need to go through 10 million images and mark the dogs in each of those images. Maybe it's more about, the algorithm tries to learn and humans give nudges to that algorithm or give feedback to that algorithm over time. And so, the paradigms of exactly how humans provide feedback to these machine learning systems will change, but it's unrealistic to believe that sort of, you're going to have AI that can just sort of like learn generatively on its own without sort of any human input or any guidance from humans to the system. I think that, even for children, they have a huge amount of instruction and direction from people in their world to be able to learn all these concepts effectively. And so I think there's sort of like this idea of like education of these systems by humans is one that will never go away. Now, the exact paradigms of how data labeling works might change, and exactly how we use fine tuning to modify existing approaches might change. But yeah, I think that sort of the intrinsic thing is that labeled data doesn't go away in the future.
And then I heard your point earlier about collecting this data, investing in this data is a leap of faith for many companies. They're not sure how they'll use it, but you're saying that if they invest, they'll find that it's useful. Is more data always better, or are there cases when having too much data can introduce noise, or how do you know you're getting the right kind of data versus the wrong kind of data? Or is that such a thing? Is just all data good data at this point, in your view?
Yeah, so there were two. So I do think it's really important that that there's kind of like good data in the form of high quality, well-annotated data. I think if you have data that's biased or data that has noise in the labels, I think that can actually introduce risk. But there's this interesting there's this interesting work from OpenAI recently. There's sort of like two main results that I think are pretty instructive. The first is they called it deep. It's called deep double descent. But basically what they found is that, like, algorithms which with more and more data effectively keep getting better for a very, very long time. There's a moment where it looks like maybe if you have too much data, you're overfitting, or you're not generalizing well enough. But if you keep throwing more data at them, it keeps getting better. And I think it's a profound result, which is that, like, if you think about it from a decade-long time scale, these machine learning systems are going to need more and more data. And the way that they get better is through much more data, more and more data. The other result that they showed was they called it, I think, the scaling laws for the deep language models. But then the other thing they showed is, like, the way that you make these state-of-the-art algorithms perform better and better is basically through ratcheting up compute, data, and algorithm size all at once, sort of like in tandem together. And so I think for a lot of organizations, like, you might not see the gains if you just independently try to increase the data set size, but you need to figure out how you can increase all the investment layers at once, like increase the compute, increase the algorithm size, and increase the data set size all together in sort of a smooth, unified motion.
Great. And since you've mentioned some of the risks of data collection and labeling, and I know in your presentation you talked about potential for bias in data, we know that training data that contains proxies for things like race can be really harmful. I know on your site you're saying you're using machine learning to label tens of millions of data points for hundreds of customers a week. Is that something that you're able to screen for, these harmful impacts in your labeling in the data that you take in from clients? And if so, how do you do that when you're doing it at such a large volume?
Yeah, identifying bias is a huge part of ensuring that these data sets are trained well. And I think that has been, if anything, I think one of the stories of learning how to productionize AI is how do you ensure that the data sets that you're training these algorithms on are actually representative of the population, representative of, like, the characteristics that you want to have in these algorithms. A lot of what we do is we work with the customer and make sure that they're always aware as there is bias in these data sets, and then produce products that allow them to better select and distribute exactly how the data needs to be done. So we built this product called Nucleus, which allows our customers to actually very specifically specify what kind of data they want to label and what that distribution should look like in the process of selecting and collecting and ultimately launching these data sets. And so that's one way in which we've helped our customers solve it. We also help our customers think about what are the forms of bias that they should be paying attention for. There's obviously forms of racial bias and gender bias, which are much more popularized, but also more subtle biases like geographic bias or age bias or cultural bias. And how to watch out for those in their data sets.
And I want to bring in a question from the audience, from Tawab. How do you identify whether the low accuracy a system is experiencing is resulting from labeling issues or from the use of incorrect machine learning models? How do you troubleshoot an issue like that?
Yeah, so it's really interesting. I think one of the really incredible things about how AI and machine learning has developed over the course of the past half decade is that many of the state-of-the-art algorithms and state-of-the-art models have actually now become open source. And so you actually have an ability, you can even just download them off GitHub. You have an ability to use, frankly, the state-of-the-art algorithms that researchers have built, like researchers at Facebook and Google and DeepMind have built, that are known to perform extremely, extremely well. And you can train those algorithms on top of your own data. And so there's some nuance to that, but one of the incredible things that I think is happening is that the best-in-class algorithms are really accessible to everybody out there, and it's really the data that ends up being the bottleneck. Data ends up being sort of the thing that not everybody is going to have scalable access to, and so I think oftentimes in training the algorithm, I think is if you're generally using the state-of-the-art algorithms that have been released, then most of the time the problem is with the data, and you'll often identify why the algorithms are performing weird or poorly from looking at issues in the data.
And another audience question. This one comes from Diego. How do we think of data labeling if your labels or intended variable outcome is obtained from measurements or instrument readings instead of from human input? So this might, I imagine, apply to some of your self-driving car projects that you've worked on before.
Yeah, I think there's a small, so it's a good question. There's a small set of I shouldn't say a small set. There's a reasonably large set of problems. There do exist problems where you know you get the data gets labeled automatically somehow. So let's say you wanted to train an algorithm that can predict the weather. Then a lot of that data kind of gets labeled quote unquote automatically because there are things that measure the weather. And so there's some subset of problems for which that you can apply machine learning to, which don't require a lot of necessarily manual or human labeling, and that's great. The issue is that for a lot of the problems that are going to have the greatest impact to human lives or the greatest impact to revolutionizing the sort of society, those are often going to require large amounts of sort of like human judgment or human annotation. So, for example, just medical, which is one of the areas that I had mentioned, to revolutionize the medical field, it's going to require an ability for us to train algorithms that can start taking off a lot of the cognitive work from that's needed in understanding and making sense of all these readings to be able to start making these processes more efficient and more reliable and ultimately safer. And that process is going to require human insight. And so I think that that both exist. There's certainly cases where we don't need labeled data by humans, but those cases are unfortunately far and few between.
And my last question, this is kind of a meta question since we're talking about deploying AI, and at your company, you've deployed AI to make it easier for other companies to deploy AI. But in speaking about your own experience in building a company that uses AI in its day-to-day operations, what have you learned about that process? And do you have any words of advice for others that are trying to do the same?
Yeah, I think that there's this like truly thinking about it as this like cycle of improvement, and how do you keep making things like, I think oftentimes when folks think about AI as something where you build something once and then you launch it and you're done, you're bound to be disappointed. The algorithms are not going to be these incredible magical things when you first release them, but it's really about getting on a cycle of, okay, how are we going to keep improving the algorithms? How are we going to keep making sure they get new data? How are we going to keep making the algorithm better and better every week? And it's really through that process that you're going to be able to build and release some incredible products using AI and machine learning. So I think it's maybe the primary advice is to be patient, but always make sure you know how you're making things better and better on a week-by-week basis.
Great. Thank you, Alexander. I think that's all we have time for, but I really appreciate you being here.
Thank you so much, Amy. These were great questions, and thanks for having me.